So I'm going to get started with our notes today. All right. Keep in mind, this is being recorded. Okay. So if you ask a question, it's going to be part of the YouTube video that I'm posting on my YouTube channel for people that miss the notes and for people that are virtual. Okay. So please don't let that bother you, but I just wanted to be really transparent about that. So every conversation is being recorded right now. So if you could, everybody has their Chem Talk notes out that you were supposed to take for section 3, chapter 4. Could you add this diagram to your Chem Talk notes? Now you're going to need some colored writing utensils. I have 3. I have these markers right here. Okay. I am not going to use these markers until I use my colored cardstock page. So I'm just being happy and putting colors around these. They don't have a purpose, but they are meant to stand out. So this is just a little bit of a review. The 2 things I wanted you to review when you drew this picture in your notes is I wanted you to review and have a good picture of what a mole was. And this goes back a few months when we had the video where we talked about that weird guy, Avogadro. And Avogadro started grouping these really small particles of atoms and molecules that we can't see even in a microscope into big piles. And he grouped them into a pile and he put them into little sacks and he pulled the string. And he said that there are 6.02 times 10 to the 23rd particles in one group. So if you don't like the idea of this little sack, maybe you could put it in a Ziploc bag. Maybe you like to use Ziploc bags instead. So if you could visualize this as a Ziploc bag and call that Ziploc bag 1 mole and realize that every time we have a Ziploc bag and it's full, it has that many parts in it. Now, since we don't have a scale that can measure moles, we have to put this little Ziploc bag of particles onto a scale. And that's what this is right here. This is my digital scale. I have the little silver thing that we put things on, and then it reads the number. So I'm going to put this little sack on the scale, and it's going to read 16 grams. And I put oxygen atoms in the sack. I put 6.02 times 10 to the 23rd oxygen atoms in my little Ziploc bag. I put the Ziploc bag on the scale, and the scale reads 16 grams. So 1 Ziploc bag, or 1 mole of oxygen, has a mass of 16 grams. Do you remember talking about this? You might remember the word mole. Because remember, this is why this guy is here. Remember? And I had a little fuzzy guy around here, but he ran away. Is he on my computer? Oh, yeah, he's buried. He's right here. So that was that day, and we're just remembering the little mole guy. It's not a little fuzzy vermin. It is actually an SI unit, standard unit of measurement for amount. Okay? So every time that we want to calculate the amount of something, we have to make sure we change it to moles. Okay? We do that in chemistry and physics, just to make things difficult. Because a gram of something isn't always a gram of something because of the density. So we have to count how many pieces there are, and the pieces are really small, so we have to put them into groups called moles. So that's how we got into this conundrum. Do you have any questions on what a mole is? So now every time I say mole, what's going to pop into your head? A Ziploc bag of little particles, and that Ziploc bag has a 6.02 at 6:02 on October 23rd. That many parts in it. Does that make sense? Okay, so now, anybody have any questions on my pictures? Are we ready to learn? Okay. So we're going to learn today about a new word. Do you need those?
What's the symbol next to 1 mole, like on the bottom? Yeah.
Oh, oxygen.
Oh, I just couldn't see that yet.
we have a new word for the day. Our new word of the day is stoichiometry. Woo! Okay, stoichiometry looks really scary, but it's not. You've actually been learning secretly about stoichiometry since 3rd grade. You've been doing stoichiometry since 3rd grade. And any time you make a recipe or anything, you are doing stoichiometry. Do you ever make macaroni and cheese?
Yeah.
What do you put in your macaroni and cheese?
Cheese, butter, and milk.
Cheese, butter, and milk. What does your cheese look like? Is it a powder or is it just a block of cheese?
It's like a powder.
It's a powder, okay. So, can you tell us the exact amounts of what you put in about?
I think it's like a half cup of milk.
Half a cup of milk,
Like 4 tablespoons of butter.
4 tablespoons of butter,
And that pouch of cheese. I don't know.
and 1 pouch of cheese. Okay? That is his stoichiometry problem for the day. So if I wanted to make 5 servings of macaroni and cheese, so let's say Will is inviting his friends over. Will, who are you going to invite to eat your macaroni and cheese in your class here?
Cody.
You're going to just invite Cody
Yeah. Cody and Alex.
and Alex. Okay.
Everybody.
Everybody, thank you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 people are coming to your house. Each of them are going to eat a whole box of macaroni and cheese. So how many boxes of macaroni and cheese are you going to make?
13 boxes.
13 boxes. How many pouches of cheese are you going to need? 13. How many tablespoons of butter? 52 tablespoons. You just did a stoichiometry problem there. You think you can do that today, but with the scary word, moles, instead? That's all you're doing. Okay, so the stoichiometry, if you read your Stioc Notes, and there's a big long definition for stoichiometry. I have a 1-word definition for stoichiometry because I like to simplify my life. The word for stoichiometry is ratio. That's all it is. Stoichiometry is just a ratio. So you could say stoichiometry if you want to sound smart, but all it is a ratio. So you're going to use a ratio to go from one thing to another. We went from Will inviting his friends over for macaroni and cheese, 2 tablespoons of butter, right? Okay, so now I'm going to teach you about 3 equivalents. So 3 ratios that we're going to learn are, the first one is the ratio between grams and moles, or moles and grams. This is one you already know. So go ahead and write this down. You're going to use these 2 dominoes to convert between grams and moles. So go ahead and add this right to your Stioc Notes that you have out. You're going to add them right to your document. I'll tell you when to write on your colored cardstock paper. Alrighty. Do you want me to show you the other domino? So there's 2 different dominoes because remember this is a domino, and what can you do with a domino? You can flip them. Because you definitely want to be your grandma on the chicken scratch. That's the name of the domino game I played with my grandma. My grandma's name is Grandma Runneroo. Don't make fun of me. But she played chicken scratch. I never win at games. I like win just a handful of times because my family is a bunch of competitive. It's a bloodbath when we play family games, and I always lose, and people laugh at me. Okay, but we don't play chicken scratch. We play other stuff. Lately, we've been playing phase 10. Has anybody played phase 10? Awesome! Does it get as violent in your family as it does mine? Yes. And who do you like to skip in your family, Allison? Please tell me it's your dad, because it would be so funny if you skipped your dad.
We play it with my neighbors. I like to skip Renee.
Oh.
My mom's lady.
What is it?
Well, it's just a card game, and you have to go through all these phases, and the first person through 10 phases wins. And you get 10 cards, and you go around, and you just follow these rules. It's a lot simpler than euchre, but I would say it's just as vindictive. And the fun person that I love to skip in my family is my husband, Tim, because he just has a meltdown every time, and I die laughing. It's the only reason I play. It's the only reason. And it's really weird. Whenever we play a game, we always get in a circle, and we're always in the circle in the same way. It's always Tim, Morgan, me, Luke. And it's never any different. It's weird. Okay, that was not about stoichiometry at all. But the 10 cards might be. That could go with stoichiometry way. Okay, so do you understand what you're doing here? Notice I have A. This is substance A. Notice all I'm doing is changing the label of substance A. I'm changing the label from grams to moles, right? Okay, so that is my first conversion, my first equivalent. We're going to use that as a tool to solve problems. Now here's my second one. Oh, I should probably show you a chemistry example. You don't have to write this down if you don't want to, but if I was doing a chemistry problem, this is what it would be. This is the molar mass of oxygen. I look up oxygen on the periodic table. I get the 16 times 2. Do you see where I'm getting the 32? Do you remember doing that?
Yep.
Then I put that over. That's equivalent to 1 mole of oxygen. And then I can take the domino and I can turn it, and that is 1 mole of O2 and 32 grams of oxygen, okay? So that is one conversion factor. And this would be a chemistry application. And since we're in chemistry, we'll do that. Then I'm going to move on to my second one, which is new. This one right here is review. This one is review. You had a step-by-step for this, remember? This right here, your step-by-step. Where you use the periodic table, and you calculate the molar mass, and you got your step-by-steps. Do you remember that? You're going to need this today. All right, the next one is changing from one thing to another. So I could change from bacteria to cars, or I could go from bananas to rhinoceroses here. Okay? That is the beauty of this. This you can convert from one thing to something completely different. Just like Will did. He converted from boxes of macaroni and cheese to tablespoons of butter. Do you see how he did that? He went from boxes to butter. I have one rule that you should not break, and notice I wrote it in caps, which means I'm doing what with it? I'm yelling it. You can never do this conversion in grams. You have to be in moles to do it. So now you can kind of understand why we had this step before. The step before is going to take our grams and convert to moles so we can do this. Okay? Now, would you like a chemistry? Oh, I should probably show you the dominoes. Here's your dominoes. Zoom in a little bit. So this would be the coefficient. The coefficient in front of substance A in the balanced equation is going to go here, and I'm going to put the word mole after it. And here's the coefficient of substance B from the balanced equation, and I'm going to put that number here and put the word mole after it. And then I can take the domino and I can turn it around. Now, would you like a chemistry example? I'm going to change something to silver. Okay? So here's my chemistry example. I'm going to take copper. I'm going to sit down so you can see. You don't go over me. I'm going to take copper and change it to silver. Okay? I'm going to put a chunk of copper in this white solution that everybody thinks it's water. It's really not. It's silver nitrate. And then after about 5 to 10 minutes, all of a sudden these silver pieces start sinking to the bottom of my solution, and I'm like, oh my gosh, I just did some magic. And everybody would think that I'm a wizard back in the Middle Ages, but I'm not. I'm just doing science. Okay, and then I can make the water turn blue as well because that's the copper nitrate. Most of the time, magic is just science or an optical illusion, which is also physics, which is science. So I'm sorry, magic really doesn't exist. I'm sorry for hurting your feelings. Okay. So what I would do to set this domino up to convert from copper to silver. So if I put in 5 grams of, or if I put in 5 moles of copper here, this will tell me exactly how many moles of silver I'm going to get. See that? So I'm going to make my domino. I get the 1 from the coefficient in front of the copper, and I get the 2. I have 2 moles, 1 mole of copper for every 2 moles of silver. So now these coefficients that you put in there actually have a purpose. We're going to use them to calculate things. They're really important. And I only need 1 mole of copper for 2 moles of silver. What a deal. That's a buy 1, get 2 for free, right? I could also turn this around and say I have 2 moles of silver for every 1 mole of copper. So do you see where those numbers come from? Does that make sense to you? Because you're going to be doing this tonight on your own. Okay, that was our second one. Our third one has to do with gases. Our third one is if it is a gas, and the gas is, I'm changing it from liters to moles, so then I don't have to have grams. I can use volume instead. This is only for gases, and the gas has to be at this temperature and this pressure. So the gas has to be at 273 Kelvin, which is 0 degrees Celsius, or 32 degrees Fahrenheit, and it has to be at 1 atmosphere of pressure. Have you ever experienced 1 atmosphere of pressure? You're experiencing it right now. You're almost at sea level. At sea level, you're at exactly 1 atmosphere of pressure, unless there is a high pressure region in the area. Right now, it's a low pressure, so it's probably a little bit below 1 atmosphere. Now we're a little bit above sea level. But if you went to the top of a mountain, the pressure goes way down because there's a column of air pushing on you. And you can feel the column of air if you put your arms out like this. You put your arms out like this, what do they start doing? They get tired. Well, one thing, the gravitational field is pulling your arms towards it, but also there's a big column of air pushing on them. So your arms got to hold that up and the mass of the arm. Did you know that? Yeah, that's all about weather. Okay, so here's your conversion. You can go from moles to liters here. So I have 1 mole that is going to be 22.4 liters. That would be quite a big balloon. Oops. That's my phone. Sorry. Don't worry, nobody loves me. It was spam.
Again.
It was spam.
Ah.
Okay. That was funny. Great jokes on this YouTube video. You can learn stoichiometry and good jokes. Okay. So, what a great way to lose friends, huh? Watch this YouTube video and learn some stoichiometry. Okay, so get your yellow paper out, or green if that's what you have. And here's what you're going to write. This is a how-to do a math stoichiometry problem. You are going to be so smart after you learn this. So smart. We're smarter than you already are. So how to do a math stoichiometry problem. All it is a ratio, but we know we can't do, we change from one thing to another in grams. So what are we going to have to do first if I get the problem in grams? Change it to what? Somebody said it. Change it to moles. So here's our step-by-step. Notice I color-coded it. So I have my colors out. You don't have to match my colors. And you can use highlighters in it if you'd like. But I'm going to color code my steps. So tomorrow or the next time I see you, when we go through our example problem, I'll color code each part of the example problem, okay? All right? So, you're going to have substance A, grams of substance A, and your first step is to change that to what? Change it to moles. So that's step one. Go from grams to moles of A. Substance A, whatever it may be. Okay? Then step two is going to go from, this is my favorite, it goes from substance A to substance B. This is the magic right here. Everybody always thinks that's magical, but it's really not. It's just science. Then step three, you can't see my three very good because I colored it purple. I can't do any, I don't have a scale in moles, so I have to change it back to grams. And I end up with grams of B. Okay? So this is a how many step process? 3-step process. And this is probably easier than any thing that you've ever done in geometry. Okay, so this is easier than a trig problem. This is easier than an algebra 2 problem. So you should enjoy this immensely. Okay? So here we go. Let's dig in. So this is because I steal things. One of the great things about being a mom is you get to steal things from your kids. And by stealing things, you also steal their ideas. So Morgan has me addicted to these. I never ever would have drank one if she wouldn't have put this in my life. But now I drink only one a day in the morning. And because of that, I'm going to calculate. It says 6 grams of sugar right there. Do you see it? Kind of. That says 6 grams. I'm going to see if I have 6 grams of sugar and I consume it, I'm going to burn it in my body. I want to see how many grams of CO2 I'm going to make from my 6 grams of sugar from my bubbler. Okay? My bubbler has antioxidants in it, which will make me live longer. I know you're all excited about that. It adds caffeine, so then I have a lot of energy to teach you stoichiometry, our favorite subject. Right? So, take a guess. How many grams, if I consume 6 grams, how many grams of CO2 do you think I'm going to crank out?
6.
Do you think it's going to be 6? Anybody else have a guess? I need a female guess. We don't want to just all be males here. Anybody want to throw a number out of female orientation?
Wait, what was your question?
If I take in 6 grams of sugar, how many grams of CO2 do you think I'm going to make?
12.
Okay, die discuss 12. So do you understand what chemical reaction this is? This is the chemical reaction for respiration, which you're all doing right now. You ate some food this morning. You're breathing. You're bringing in some oxygen. This is a combustion reaction. So you're combusting things in your body right now. That's why you feel hot, because it's an exothermic reaction, right? You breathe CO2 out, and you also make some water. Okay? Sometimes you use the water for other things in your body, and other times it does what? Ends up in your pee. Yes. So do you see, this is like our homeostasis right here of life, all from my bubbler. Okay? So now, let's do this, shall we? Step 1. Notice it's pink, because it corresponds to my step up here. Do you see that? So my first step is to go from grams of A, which in our case is sugar, to moles of sugar. So I'm going to change from grams of sugar to moles of sugar. Have you ever done a problem like this before? Yes, you have. You know how to do this. You've done a problem like that. You actually did it on your last test, right? Do you remember this? So if you don't remember this, you have a step-by-step in your notes. It looks like this. You're welcome to get it out if you want. I'm just going to do it rather than write all the steps down again. Do you remember what step 1 is? What is step 1?
Write down what you already know.
Write down what we know. So what do we know?
Well, we know that there's.
So, don't we molar mass the sugar thing, and then we see how like 6 grams, we see like how many times 6 grams goes into whatever the total is, and then we divide that by that, and then that's how many moles we got.
Yes, okay, stop there. We got to do the step. So we got to write all that out. You remember, we got to write down our given information. We got to draw an X. We got to draw a line. We got to draw an equal sign. Do you remember all that? Okay, so let's do it, shall we? So I'm going to redo it.
This one.
So here we go. So I have 6 grams of sugar from my bubbler, and it tasted delicious, and I really enjoyed it. Then I'm going to write a multiplication sign. I'm going to draw a line. I'm going to write an equal sign. Remember all this? And then I need to write down what I need to find. What is the label for my answer? Well, what's my label going to be?
Moles.
Moles of sugar. Moles of sugar. So do you remember what I do with this moles of sugar? Where do I put it?
On the top.
On the top. Everything that you want to end up in goes on top. Everything that you get rid of goes on the bottom. We learned that rule the first thing you did in your investigate, right? Do you remember the dominoes? Okay, so I want to end up in moles. What am I going to put on the bottom? Grams of sugar. So now I'm going to get out my equivalents that I just wrote down. I just wrote them down right here. Which one am I going to use? I have moles on top right here. Am I going to use the molar mass one, or am I going to use the moles one? And then this matches, so that means I have to put this 1 in. And then I need the molar mass on the bottom. Do you remember how to do molar mass? Molar mass is where you list all your elements, and you write the subscripts down. Do you remember that? And then you multiply. Where do I get the numbers that you multiply from?
PT.
My periodic table, right? So, anybody want to look up carbon, hydrogen, and oxygen? We could do a tag team here. Does anybody have them memorized yet?
Is it hydrogen or oxygen 15.998?
And that rounds to 16.
What do we-
Hydrogen, and we're going to make sure we go to 2 decimal points. So hydrogen is 1.01. Thank you, Dada. How about carbon? Will, you had a question?
What?
You had a question.
Alright.
Were we? You forgot it?
Oh, I was gonna ask how many decimal places you want us around.
2, please.
Carbon is 12.01.
12.01. Anybody want, we need to get our calculators out, unless we have a math mind on the crunch. This one is 12.12.
That the top one's 40. Oh, that's like
Not 40.
it's like 72.06.
Yes. Okay, anybody know what 6 times 16 is?
Yeah, 96.
Okay, add these up for us. No, it's going to be 100 something.
I actually don't know this. Oh, it's like 180.18.
Point.
What?
Yeah, 180.
Okay, so we have confirmation. So this is how many Ziploc bag. This is how many grams are in one Ziploc bag of sugar. So if I take a Ziploc bag of sugar and I put 180 grams in it, that's 1 mole of sugar. That means I have 6.02 times 10 to the 23rd particles of sugar in that Ziploc bag. That's like a cup and a half of sugar. Mountain Dew has that much sugar in it. 1 can. It might have more. I'm going to take that and put that up here. Then I need to do my math. So 6 times 1 divided by 180.18. What do you get? Help me out, people with calculators.
Wait, what did you do?
6 times 1 divided by 180.18. Anybody have calculators out?
0.0333.
Thank you. Do we have confirmation on that? Do we have confirmation on that number? We don't know if it's right. Is that the to-go bell?
Oh, yeah, that's right.
Looks like we'll have to do this one.
Wait, how did you get 0.03?
I took 6 times 1 divided by this.
Oh.
I'm going to continue making my video and post the video online. You're going to have to do your homework, trying, not crying. This Ron Phil will give it to you as you leave.
So you just do that for the rest of them.
So then I'm going to take this answer and I will go to part 2. Okay? So part 2 is going to be green because I'm going to go from moles of A to moles of B. So I'm going to take my answer from part A, and that's going to be the starting point for the second problem. And then I'm going to set up my domino. So quiet, keep your voices down because remember I'm making a video for you. So I'm going to make use a domino here. These dominoes right here. So I'm going to take the moles of sugar because I want to get rid of that. And I want to end up in moles of CO2 because we have the question mark after it. So I'm going to take and look at my coefficient in front of sugar. And it's a 1, so that's where this 1 comes from. And I'm going to look at the coefficient in front of CO2. And that is a 6. So I'm going to write a 6. Then I'm going to take 0.03 moles of sugar times 6. And I'm going to get 0.18 moles of CO2. Now we know we want our answer in moles of CO2. So that's going to lead to step 3. Step 3 is to convert from moles to grams. And here is how we do that. So step 3 is purple. I'm going to take my answer from the last part, and I'm going to use my ratios here. I have grams on the top. So I have, I'm going to use this one right here. So I'm going to put the molar mass of CO2 on top. And I'm going to put 1 mole of CO2 on the bottom. So 1.8 times 44.01, and I get this many grams. And that's how many grams of CO2 gas I create from 6 grams of sugar.